Hi, I'm Eve Griliches with ACG Research, and I'm here today with Ron Johnson, the Director of Architecture and Technology at Cisco. I want to ask you a few questions, Ron, if that's okay.
That'd be great. Nice to see you.
Nice to see you. Now, you just made an announcement on nLight a little while ago. Can you tell us a little bit more details about what nLight really is?
Yeah, I'd love to. There's really three pillars to what nLight entails. The first pillar has to do with silicon, and there are two acquisitions that Cisco's done recently, or in the past couple of years, that have led to driving more silicon, Moore's Law value into optics. One is with core optics, leveraging digital signal processors for coherent detection, and the other is Lightwire, and being able to drive the optical components into a silicon device. The second pillar is the control plane. Right? We've done a lot of work over time with a control plane at the optical layer and a control plane at the packet layer, and we want to facilitate a communication between those two. We call that nLight control plane. Mm-hmm. And the third is really around ROADMs becoming completely flexible, so that when you hear about all the terms like contentionless, colorless, omnidirectional, flex spectrum, that all of that encompasses a touchless ROADM that allows you to rearrange your network without physically moving fibers.
So what are the problems that nLight really solves out there? I mean, what are service providers challenged with that this is really going to help with?
I see two major components to what nLight is really focused on as an in value. One is to be able to continue down the path of creating denser and denser products at a lower cost per bit and lower power.
Okay.
Right. The other piece that I think is really important is more of a network level functionality, which is the ability to have more awareness about the other layers in the network and be able to make intelligent decisions that allow you to both be more resilient and optimize the network.
So that sounds really good. Can you give me a little bit more details, because, on sort of the nLight control plane and how it might relate to the IP and optics convergence? Because it sounds like it's really sort of trying to pull that all together.
Yeah, I brought a visual. Let me share the visual with you
Okay.
and describe what we're doing there.
Great.
So we start with the nLight control plane with an optical layer, and that's what I've shown here in blue. And the optical layer really has the new added functionality that I described as part of nLight, which is complete flexibility, and a control plane that enables you to be self-aware. So in the past, where you've had to move fibers and physically go to an offline design tool to determine if a circuit can work over the optical layer, now the combination of control plane and flexibility in the optics allows the optical layer to be completely flexible. If we look at how the IP network works with that, today it typically is unaware of any of the details in the optical layer. And what we want to facilitate is the ability for the optical layer and the IP layer to have a more rich communication channel.
And it's true, because if you look at that, the topologies are really different between the IP layer and the optical layer.
Absolutely. The topologies are different. The definitions of simple terms like core and edge and access, you have to work very closely together to even understand what they mean across these different teams. So right. Aligning on that common vernacular, as well as creating this mechanism for the layers to talk together, is where nLight is driving the industry forward. This channel that works between the layers is based on GMPLS. It's more than the overlay model and less than the peering model. So it provides a mechanism to share only what's needed to be shared between the layers, and it starts to enable things like restoration, right? Where restoration at the optical layer could change completely the dynamics of how the path latency is looked at, what the shared risks are at the IP layer, and we don't want to do that blindly, right? We don't want to do that at the optical layer and then just assume that the IP layer is okay.
Right.
So in order to address that, we create a circuit awareness. So there's a circuit ID that gets attached to each interface that connects the layers together.
Okay. Then
we add latency attributes, so that if you have a particular service that you're running at the IP layer that's latency sensitive, that it won't allow the optical layer to rearrange itself into a path that doesn't meet that latency sensitivity. And then shared risk link groups, I think, are really important because as in the IP layer, you may have protected circuits that really rely on complete diversity. And that diversity in the past was guaranteed just simply through provisioning. And because provisioning was so hard and took so long, like months in many cases,
right.
You didn't automatically re-provision when you could optimize a network. You just simply left what was out there in place. But now that the optical layer has the opportunity to rearrange, we have to create an awareness about shared risks that exist to assure that we don't have a working path and protect path put over the same device that could create a common failure.
And the whole shared risk group thing I think is really interesting. Can you just describe what can happen if that's not done properly?
Yeah, and we hear this a lot that, service provider says, we thought we had it all figured out. We had, done this and this and this, but then at some point we went in and made some changes to the network. We didn't think about the implications on the other layer, and we only really realized this when we had a failure and we lost, that part of the network over there, or that city over there, right? And this is, I think, a very real problem and a real challenge. In fact, not only is it the IP layer and the optical layer, but we're also looking at how do you start to talk to databases that are aware of fiber facilities, entrance facilities, maintenance holes, so that these ducts can be addressed as part of the scheme. So there's a lot of rich capability that can come through automation that make it so that the layers can become completely flexible and be able to start to do even more interesting things in the future.
Sounds like a lot of visibility.
Yeah.
So how is nLight different from what else is out there today? I mean, how is somebody going to be able to compare this?
Yeah, I think the thing that really makes nLight complete is that it's connecting a lot of dots together, right? It's connecting the network processor, right? It's connected to the digital signal processor and the coherent detection mechanism, to the optics, to the ROADM itself. And by chaining all of that together and creating this intelligence across all of those layers, we can really start to leverage that communication to optimize it completely.
That's great. Thanks a lot, Ron. We really appreciate it on this Tech Talk today.
Thank you.
Great.